so we have some special cases of equations that when we solve, something different kind of happens. And so we also have types of equations when we solve that have no solution, infinite solutions, or they're mixed. There could be one, none, or infinite. So we're going to go through those. I'm going to pause to go down to the next page. Equations have no solution if they are always false. We write a 0 with a line through it, which is called the empty set. So when we're solving our equation, and these were the grade level equations, I always want to check my parentheses first. And inside my parentheses, I can't simplify because they're different terms. But I have this negative 3 on the outside. That negative 3 means I need to distribute negative 3 to the parentheses. That means I need to take negative 3 and multiply it to 4x, and negative 3 and multiply it to negative 5. So when I have parentheses, I always take the number and sign out in front, and I distribute that number to everybody inside the parentheses by using multiplication. So I get negative 12x plus 15. That is a positive 15 because I have a negative times a negative. I can also view that as the opposite of negative 5, which is positive. My equal sign comes down, and my negative 12x plus 10 comes down because I didn't operate on that. Next, I need to isolate my variable. So I'm going to identify one of my variables. I'm going to do the negative 12x on the left, and I'm going to add 12x, which is the inverse operation. That is the opposite of subtracting x, is to add it. That zeroes out, and I'm left with 15. On the left side, on the right side, when I combine like terms, that also zeroes out. And that's what needs to happen here. That's how you know you have a special case. And I'm left with 10. 15 equals 10. That's where the falsehood comes in. That's not equal. That's false. So that's how we know we have no solution. And we can write that solution with the 0 with a line through it using the empty set symbol. Or we can write no solution. So with equations that have no solution, there is no possible value for our variable that could make the equation true. Because they cancel out, I no longer have a variable. And that means if this is false, then no matter what number I put in there, it's not going to be a true statement. It's always going to be false. So in my next problem, I have two sets of parentheses, and just like order of operations, I'm going to look at the first set and work left to right. So I can't simplify inside, so I'm going to look at that number on the outside. I have a negative 2. That's going to distribute to x and to negative 5 by multiplication. So I get negative 2x plus 10. Then I have my second set of parentheses, x minus 1, can't simplify inside. I'm going to take a look at the number on the outside. But there's not really a number there. There's just a negative sign. I can write a number there. I can write a 1, and it can be a negative 1. Or I could view the negative sign as the opposite. I need to take the opposite of x, and I need to take the opposite of negative 1. That gives me negative x plus 1. Then I bring down my equal sign and my negative 3x minus 11. Now I need to combine like terms. Before I go any further, I need to see if I have any x terms that can be added together. I have a negative 2x and a negative x. They can combine because they're on the same side of the equal sign. They're both on the left. That gives me a negative 3x. I can also combine a 10 and a 1 because they're on the same side, left side, and they're alike. So that gives me negative 3x plus 11 equals negative 3x minus 11. Okay, now that I've simplified by combining like terms, I'm going to isolate the variable. So I'm going to take the negative 3x on the left and add it to the 3x on both sides. Okay, negative 3x plus 3, that cancels out. It also cancels out on the other side. That's another indicator that you have a special case. What I have left is 11 equals negative 11. That is also false. They are not equal. So this is another example of where we have no solution. No number for x will ever work in this equation. Okay, then we have a special case where we have an infinitely many solutions. Equations that have infinite many solutions if they are always true. We write this R symbol, which is called the set of all real numbers. Again, I have two sets of parentheses. I'm going to work left to right, so I'm going to work 3x minus 1. That's already simplified. It has a 2 on the outside, so I need to distribute the 2 by multiplying everybody inside the parentheses by that 2. I get 6x minus 2 plus 10 equals, and then I have the parentheses here with x plus 4. I can't simplify on the inside. That 6 on the outside can be distributed by multiplication. I get 6x plus 24 minus 16. So now I need to combine like terms. On the left side, I only have the 6x term, so that's the only term there. If there's nothing to combine, I'm going to bring that down. I have a negative 2 and a positive 10. That does combine to equal 8. On the right side, I have 6x plus 24 minus 16. 6x is the only variable term, so I'm going to write that down. And then I have 24 and negative 16 that can be added together. That gives me plus 8. Then I need to isolate the variable. I'm going to subtract 6x from the left side and subtract 6x from the right side. And you'll notice, just like the no solution, they both cancel out. But this time I'm left with 8 equals to 8, which is a true statement. And since it's a true statement, that's what makes it infinitely many solutions. So that real number symbol, I have 2 lines and then I make an R. That's the real set of all real numbers. Or I can write infinitely many solutions. So with our next example, equations that have infinitely many solutions, any possible value for our variable will make the equation true. So that means no matter what number I pick, it's going to work in the equation. Sometimes we also write the infinity symbol, which kind of looks like a sideways 8. Looking at our equation, I'm going to focus on my parentheses first. Parentheses do come first. Inside, I cannot simplify. They are different terms. On the outside, I do have that 3. So that 3 can be distributed by multiplication. I get 6 minus 12x, and then I bring down my plus 7. That's the right side of my equation. I'm going to rewrite my left side. 13 minus 12x. I need to combine like terms. I do not have any like terms on my left side, so I'm going to rewrite it. 13 minus 12x equals, I do have terms to combine on the right. I have the 6 and the 7. So what I have left is negative 12x plus 13. Now that I've combined like terms to further simplify my equation, I need to isolate my variable. I have a negative 12x, so the inverse operation is to add 12x to both sides. That 12x zeroes out, but it also zeroes out on the right. So now both my variables have canceled each other out, and I'm left with 13 equals 13. That's a true statement. That's true. So then I know I have infinitely many solutions. Infinitely many solutions, and that's using the infinity sign. So what you'll notice, some similarities when it's a special case. The variables canceled out. The variables canceled out in every situation. It's canceled out with the no solution. The variable zeroed out with the infinitely many solutions. Now, the difference between them is that we had a false statement when they were no solution, and we had a true statement with the infinitely many solutions. So to sum it up, equations that are always false have no solution. Equations that are always true have infinite solutions. And equations that are true for only one number have one solution. That means that you're not going to cancel the variables out. You are going to be able to solve for x. Okay, I'm going to pause the video here and do a part 2, and I will do these 3 examples on the bottom.